Okay, so we want to look at the solving for this. They said what is the empirical formula of L-Dopa, a drug that is used for the treatment of Parkinson's disease? It has the following composition. Of course, the empirical formula, if you must solve, you have to first of all list out the element that is contained. So we have C, we have H, we have N, we have O. So we're going to write down the percentage by mass of each of them. We have this other one, but you notice that H was not given to us. All right, N is 7.10, oxygen is 32.46. So in this case now, since they all gave us since all these values were given to us in percentage, so we'll now say percentage of H equals to 100 minus percentage of carbon plus nitrogen plus oxygen. So this is equals to 100 minus 54.82 plus 7.10 plus 32.46. So if you subtract this from 100, we'll have this to be 5.62%. So that means, so therefore, percentage of hydrogen is 5.62%. So we can now come back here and put hydrogen to be 5.662. All right, so we've seen how we got the hydrogen. So we need to actually proceed with our solving. So you come here, erase all of this. Okay, so for us to solve this, you divide by the atomic masses. Now, carbon is 54 point. They gave us, now atomic mass of carbon is 12. Atomic mass of hydrogen is 1. Atomic mass of nitrogen is 14. So in this case now, when you actually press your calculator, we have, it becomes 2.029. And this other one becomes 0.507. This other one becomes 4.568. So the next thing we're going to do here is to divide through by the smallest. So we'll say divide through by the smallest. So we have the smallest of all of them is this guy. So say 4.568 divided by 0.507. We have 0.507 divided by 0.507. We have 209 divided by 0.507. Now when you press your calculator, you're going to have 4.568 divided by 0.507. So this becomes equals to 9. This is approximately 9. And this other one is 5.62 divided by 0.507 is approximately 11. And this is 1. And 2.029 divided by 0.507 is approximately 4. So therefore, the empirical formula for that compound becomes C9, H11, and O4. Okay, so that's the empirical formula for this particular one here. Okay, so when we look at the next one, look at the next question. It said, what is the amount of calcium phosphate that can be prepared from a mixture of 9 grams of calcium hydroxide and phosphoric acid? So first of all, you have to write the balanced equation for this guy. So if I do that, let's raise this guy up a bit. So I'll say the balanced equation for this guy would be, we have calcium hydroxide plus phosphoric acid. We have this to be Ca3 PO4 plus water. Because this is considered, this is a base, right? This is a base, this is an acid, so it's going to give us salt and water, but then we have to see how to balance the equation. All right, so let's see how to balance the equation. We have 3 calcium here, so we have to add 3 here to balance this calcium. We'll balance the calcium, so by adding 3 here, we've increased the hydrogen here to 6, plus this other one here. So if you look at P is actually 2 here, so you must add 2 here as well. So by adding 2 here, you've increased the hydrogen to 6, you've increased the hydrogen to 6 here, so that's 12. So basically going to say 6 here. Now if you add this, hydrogen becomes 6. Now let's check out for the oxygen. Oxygen is 4 times 2 is 8 plus 6, that's 14. So we have 2 times 4 is 8 times plus 6 is 18. So the equation is balanced. So the first thing you're going to do is that we are asked to find the mass of this guy, amount of calcium that will be produced if you react 9 grams of this and then 11 grams of this. Now first and foremost, this particular question, assuming they had given us only the mass of one of the reactants, we would have just proceeded to solve. But this particular question, since they gave us the mass of 2 reactants, we have to find which of them is a limiting reagent. For instance, now this is what I mean, you cannot actually determine which of them is a limiting reagent. Now assuming they give us the mass of calcium hydroxide alone, I'd have said, okay, 3 moles of calcium hydroxide gives 1 mole of this, so you convert this mole, this guy will now give us X. But for the fact that they gave us the mass of calcium hydroxide as well as the mass of phosphoric acid, So we have to first of all find which of them is the limiting reagent. All right, so that is actually going to give us an idea of the one we are going to use to get the product. So I'll say first solve for the limiting reagent. Now for us to solve for the limiting reagent, we're going to put down the two reactants, and then we want to find out which of these two will finish first. That's what we want to do. Whichever of them finishes first is actually going to be the one that will give us the right product. Because for instance, if you have a reaction, or if you're cooking now, your stove and your wool and your kerosene, which of them finishes first determines the the level of the food. The how will I put it now? Okay, let me use car and Ford for example. If you're driving, the car in your Ford determines how far your car would go. So once your Ford finishes, your car will stop. So the distance covered by your car is somehow determined by the amount of fuel present inside. So that is it. So we start by solving. We say, what is the mass of this guy? The mass of calcium hydroxide they gave to us is 9 grams, and the mass of this guy is 11 grams. Now we'll convert this guy to mole. First, we need to solve for the molar mass of calcium hydroxide. Molar mass of calcium hydroxide is OH is 17 times 2, that's 34. 34 plus 40, because calcium is 40. So this is going to be divided by we have 40 grams per mole, and then we have oxygen to be 16. Oxygen is 16 times 4, plus we have phosphorus to be 31, plus we have hydrogen to be 1 times 3. This becomes 98. So we say sorry, this is actually not 40, right? This is not 40. Sorry for that. The molar mass of this guy is basically going to be, now calcium is 40 plus OH is 17, 16 for oxygen, 1 for hydrogen. 16 times 6 is 34. 34 plus 40 is 74 grams per mole. Now this other guy here is 98 grams per mole. Alright, so when you do that, we'll say 9 divided by 74. Now this gives us 0.16122 mole. And this other guy, we have 11 divided by 98. This gives us 0.112 mole. Now what we are going to do here, remember this stuff was to divide by their molar mass. To get the mole. So now we've gotten the mole. The next thing we're going to do is divide the mole by their stoichiometric coefficient. Right, so when you divide the mole by their stoichiometric coefficient, this becomes from the balanced chemical equation, you can see that calcium hydroxide has a coefficient of 3. So you say 0.122 divided by 3. You say 0.112 divided by 2. Alright, so we have this guy to be 0.122 divided by 3. Now this becomes 0.041, and this other guy becomes 0.112 divided by 2. We have 0.056. Now the big question is the limiting reagent. Now the smallest amongst these two values means that the one that is the smallest is going to finish first. So the one, whichever one that finishes first determines, right, the extent of which that reaction would go. Just like I gave us example illustration previously, if you're driving, what your car needs to drive is oxygen and air. These are the two basic stuff, reagents, right? Okay, if your fuel finishes, the car is definitely going to stop. So in this case now, the fuel inside your car kind of limits the distance traveled by your car. So in this case now, same thing in chemical reaction. We have limiting reagent and we have excess. So what we just did here is that after solving this, you realize that 0.041 is smaller, is smallest compared to these two. So it means that this 0.041 is actually value for calcium hydroxide. So it means that the calcium hydroxide is going to finish first. Okay, so since we've gotten the limiting reagent, it's now time for us to solve back. All right, so I will actually encourage us to quickly run through this, because I would want to erase this particular one here and then comment the solving proper. So since we are now aware that the limiting reagent is now calcium hydroxide, so it's very important for us to now proceed with the main calculation. All right, so take note of that. Okay, so let's look at the main calculation class. So we'll have so I'll clean this off. I'll say okay, so in this case now, we have calcium hydroxide. So we say limiting reagent is now calcium hydroxide. Okay, so basically what we're going to do here is that it is actually the calcium hydroxide that will give us the exact amount of the product, which is what we are asked to find. So come here, from the equation here, you can see that 3 moles of this will give rise to 1 mole of this. And remember, I told us that 3 moles of calcium hydroxide will give rise to 1 mole of calcium phosphate. Now, remember, the mass inside 1 mole is molar mass. So for us to get the mass inside 3 moles, we're going to say 3 times the molar mass of calcium hydroxide, which is 74 grams. We had earlier gotten that previously. 74 grams of calcium hydroxide, right? Now let's see, this is 1 mole of this is going to be, the mass inside 1 mole is a molar mass. So what is the molar mass of calcium phosphate? Now let's quickly run the calculation here. Phosphorus is 31. Okay, oxygen is 16 times 4, which is 64, plus 31. So everything inside the bracket is 95, but we can see times 2 there. So that is 190, plus calcium is 40 times 3. So that is 310. So the amount of the molar mass of calcium phosphate is 310 grams. So say 310 grams of calcium phosphate. All right, so if 3 times this equals to, give us this. Now, what was the mass of calcium hydroxide that was given to us in this question? 9 grams. So say 9 grams of calcium hydroxide will now give us X. Now, from the calculation, you can see that 3 moles of calcium hydroxide will always give rise to 1 mole of calcium phosphate. All right, so from you convert the mole to mass, the mass inside 1 mole is always a molar mass. So since you can see 3 moles here, you're going to say 3 times the molar mass of calcium hydroxide. Now it's going to give rise to 1 mole of this, and the mass inside 1 mole of calcium phosphate is a molar mass. So this is 1 times the molar mass of this. So if this times 74 give us 310, so 9 grams is going to give us X. Now you're going to cross your multiply. When you cross your multiply, so this is what basically we're going to have here. Just let me press calculator. So this becomes X equals to we have 9 grams times 3 10 grams divided by 3 times 74 grams. All right, so this becomes 9 times 310 divided by 3 times 74. So we'll have equals to 12.56 grams. So therefore, amount of calcium phosphate that can be prepared when you mix this and this is going to give us 12.56 gram calcium phosphate. Okay, so that is the answer for this particular stuff here. Okay, so let's look at the next question. So we have the molarity of concentrated hydrochloric acid is 12.0 molar HCl. What volume of concentrated hydrochloric acid is required to prepare? All right, basically this dilution formula. So we're going to say this particular one here. It's actually is a dilution question, right? They gave us a concentration that is very concentrated, which is 12.0. And they're asking us to check out the volume of this molarity that we can dilute to this. Just like you bring in a very hot water that is very hot, and then you're being asked how many liters of very hot water can you actually bring, so that when we dilute it, we're going to get something very large. You could imagine you can just bring as little as 1 custard of hot water and pour it inside your bathing bucket. You realize that you're going to dilute that water and then it's going to fill up a 20 liters bucket. So that's basically what this question is all about. So you're diluting a concentrated acid. So the concentrated acid, you must bring a particular volume of it. So we say the initial concentration of the acid equals to M1, which is 12.0 molar, right? Initial volume is actually what we are asked to find of acid, equals to V1. That is what we are asked to find. Now the final volume, final concentration of acid is M2. All right, so we have 3.55 molar. Final volume of acid is equals to 25 liters. So we're going to use dilution formula, which is M1 V1 equals to M2 V2. Remember, we're looking for V1, so we'll say V1 becomes equals to M2 V2 all divided by M1. So this becomes equals to, what is our M2? M2 is 3.5. What is our V2? Please, this is this guy is our M2 and this guy is our V2. All right, so our M2 is 25 liters. Now all over our M1 is 12.0. So when you do your calculation, this now becomes equals to 3.55 times 25 now divided by 12. So we have 7.4 liters approximately, because they're 7.39, so you approximate it. So it simply means that what volume of concentrated hydrochloric acid is required to prepare. So we need, so therefore volume of conc HCl required to prepare 25 liters of this is 7.4 liters. This question is under dilution. All of these questions, we are going to solve it in a normal class. Please make sure you hit the subscribe button, okay, because more and more videos will be dropping on this channel. And of course, if you hit the subscribe button below, make sure you turn on the bell notification so that all your assignment questions, your practical questions, your test questions, all of them will be solved and dropped on this channel, as well as the textbook exercises. All right, so you don't really have to wait until you're being given a question in class. You can just go through the channel, solve as many questions as possible, so that when the lecturer finally gives you guys question in class, you don't have to wait and then rush to submit. Okay. All right, so let's look at the next question here. Let's look at the next question. So if we have this, calculate the average atomic mass of neon if the natural occurring neon has following composition. Right, so relative atomic mass, we have relative atomic mass, which is the same thing as average atomic mass. It's more like saying isotopic mass 1 times let's say times abundance 1, close your brackets, plus isotopic mass 2 times abundance 2, close your brackets, plus isotopic mass 3 times abundance 3, close your brackets. This is all divided by now 100. Now this 100 is not as if it's always a constant. It's actually because the percentage abundance that was given to us in terms of percentage. If the abundance here were not given to us in terms of percentage, if it was given to us in terms of decimal, right, like 0.9, like this first one now, if they divide 90.51 divided by 100, it's going to give you 90.51 divided by 100 is going to give you 0.9051. Now, assuming they had given you guys the abundance of this guy in decimal 0.9051, please, you won't be dividing by 100, you'll be dividing by 1. The main purpose of what dividing this guy by 100 is because the percentage abundance was given to us in terms of percentage. The abundance was given to us in terms of percentage. Okay, so the first isotope is neon, and the mass of the first isotope is 19.99244. The percentage abundance of the first isotope is this. Now this is a second isotope, so this is the first isotope. Now this is a second isotope. The mass of the second isotope is 20.99395, and the percentage abundance of the second guy is this, and this is a third isotope. So basically what we're going to be doing here is to be substituting the values. Now the isotopic mass 1, which is the first isotope, has a mass of 19.99244. Now the mass will always be given to us in such a way that when you approximate it to give us this mass number, which is 20. Now times the abundance of the first one is 90.51, right? Now this is plus the second isotope is this guy, 20.99395 times, okay, we have the abundance of this other guy is 0.27 plus, now this is 21, the third isotope is 21.99138 times 9.22%. Now this is all divided by 100. Now if you press your calculator, let's do that fast, and we have 19.99244 times 90.51 plus 20.99395 times 0.27 plus 21.99138 times 9.22. Now, if you notice, you must add up all these percentage to give you 100. Sorry, so let's take that again. We have 19.99244 times the first abundance, which is 90.51. You close your bracket, open another plus, plus open a bracket 20.99395 times 0.27 plus we have 21.99138 times 9.22. Now this is all divided by 100. So your answer here, so we have the relative atomic mass, which is written as average atomic mass, equals to 20.18 approximately AMU. This stands for atomic mass units. Right, this particular question is under isotopes, and I've done this in class. All right, please make sure you actually hit the subscribe button. All right, because more of this will be dropped on the channel. Hit the subscribe button below. Please comment, share the video to your friends, so they don't have to copy your own assignment. So you can just share it to them so that they can actually write it from